we're going to solve systems of equations. This is actually some pretty basic ones from section 11.1 and some more complicated ones from 11.8, which are nonlinear. So just understand your homework is actually on 2 different pages. I felt like I could combine these two without being too much, because the first one you've really learned how to do. Like, I think you know how to solve using substitution. If you take these two, you could solve this one. This seems obvious. Maybe just solve this for x. Maybe get that to the other side. So add 3y to both sides. So you get x equals 3y minus 17. Of course, that's going to get plugged in everywhere there is an x, right? In the other equations, you solve one of the equations for one of the variables and you plug it in. So this would be 2 times, instead of x, it's going to be 3y minus 17 plus 3y equals 2. So distribute there, we get 6y minus 34 plus 3y equals 2. I'm going to add 34 to both sides, kind of combine like terms, so I get 9y equals 36. Divide by 9, divide by 9. Y equals 4. You've probably seen this kind of problem before. Now, we're not done. Of course, at this point, you've got to plug that in. I would plug it in over here just because it's already solved for x and figure out what x is. So we got to get x and y. X equals 3 times 4 minus 17. So x equals 12 minus 17, which is x equals -5. Now, the answers in this section I want written a certain way. So I want it written as an ordered pair. So I want -5, comma 4 would be the answer for this one. So that's like your x, comma y, right? So don't write it like x and y, because we're going to get to some more complicated problems that have multiple x's and multiple y's. I want to know which one goes with which. So I want you to get in the habit now, which is writing your answer in this chapter as ordered pairs. We're solving a lot of systems in this chapter. Different ways of solving systems. We're solving lots and lots of systems. Okay, so I think same one, but we're going to do this using elimination. So let's try that. So I'm going to kind of line them up. And if you line them up, the x's are lined up, the y's are lined up, the equals are lined up. That's kind of important. Numbers and constants on the right are lined up. This one seems easy. You would just add. If I was to try to get rid of the y's, if I was to try and get rid of the x's, I could multiply everything in here by -2. Do y'all see that? And that would make this -2x, which adds to make 0, positive 6y, plus 34, and add it up and do it that way. However, I'm going to do it the easy way here because it's already set up. Like, it's not bad, right? So you're going to add, because this is called elimination, because you're going to eliminate through the variable. So if I add the 3y, -3y is gone away. There's no more y's, so I get 3x equals -15. So divide by 3, you get x equals -5. And then we take one of those equations. It doesn't really matter which one. I'm just going to take this one. So it's going to be x, which is -5, minus 3y equals -17. Add 5 to both sides. Divide by -3. I get y equals positive 4. So my answer is -5, comma 4. The answer looks kind of familiar. I think it is the same answer. Oh, it's the same question. That's probably why, right? So we just solved it a different way. Graphing method. So this is the graphing method. I would expect you to go and write this down first, and we'll solve this using graph. Solve both equations for y. Graph both equations. This might be in your calculator or it might be on paper. This first one I think is going to be a calculator, but we could probably do it on paper too as well. But if this one doesn't work out as well on paper, I'll give you a nicer problem if it's on paper. And then find the point of intersection. So I'll show you how to do that. So we're going to solve this for y. It takes a couple of steps here. So we're going to subtract x. Get -3y equals -x minus 17. Divide by -3. I prefer to divide each term by -3. I think it's easier to cancel. So I get 1/3 x plus 17/3. Yeah, that'd be hard to graph by hand. Okay, this one, if I solve it for y, I get 3y equals negative 2x plus 2, divide by 3, divide by 3, divide by 3. I get y equals negative 2/3 x plus 2/3. Again, a tough one to graph by hand. Okay, so I'm going to graph each one of these. So 1/3 x plus control divide 7/3. Press enter, hit tab to graph the next line. So negative 2/3 x plus control divide 2/3. Okay, so you can see where those two lines cross, and we're going to find the ordered pair of those two lines. By the way, I think I didn't type that right, so it should say 17/3 there. That's what I see down here on the page. There we go. That looks right. So let's use our calculator to find this. You might just be able to find the point there, but it's much easier to actually use your calculator to do this. So my favorite way is to go to geometry. So you go menu, geometry. We're looking for intersection point. So it's under the points and lines, and there it is, intersection point. If you don't know how to use that tool, if you hover over the icon in the corner, it tells you click on the first graph, then click on the second graph. So click on the blue graph, click on the red graph, and it tells me that ordered pair is -5, 4, which is the same answer we got before. So I was kind of expecting the same answer, and we did get the same answer as long as I type in 17/3 rather than 7/3 there. Okay, so that is how the method to graph. Again, if it was an easier graph, we might do that on paper and graph it, but this one, calculator for sure. Okay, watch out for these two cases. So you've probably seen these before. You could use elimination or substitution. I'm going to try elimination here. So I'm going to multiply everything by -1. So if I do that, I get y equals 2x plus 3. Well, that's just the same. This one gets -y equals -2x plus 4. So if I add those things together now, the y's go away, I get 0. Y minus y is 0. The x's go away, I get 0. 3 plus 4 is 7. I get 0 equals 7, which is not actually true. So if you get something that's not true, the variables all go away. That was kind of surprising that I eliminated both x and y, but that happens sometimes. And so this is a case where there is no solution to this problem. Graphically, if you looked at this, from a graphing perspective, this is just a really rough graph. The graph of this one has a positive slope, looks like this top one, looks something like this, roughly. And then this one here looks something roughly like this. Now, if you can tell, but those two lines are parallel. They have the same slope, right? So, but different y-intercepts. So they're never going to touch. They're parallel lines, so there is no solution. We're looking for where the graphs cross, right? So if those graphs don't ever cross, they have the same slope, different y-intercept, it's going to be no solution all the time. So that's going to happen sometimes, is you're going to have sometimes no solution. That's kind of a weird case, but it does happen. With this one, let's just, instead of multiply by -1, let's just subtract these two. So you get y minus y is 0. Negative x minus negative x is 0. You get 1 minus 1 is 0. So I end up getting 0 equals 0. Well, is that always true? I think that is always true, right? So this would be a case where there is an infinite number of solutions. And let's talk about why that is. So if I were to graph these two lines, roughly, this one might look roughly like this. And this one might look roughly like this. However you can tell, but those are the exact same line. How many solutions are there? Well, that's a solution, that's a solution. Every single point on this line, and there's an infinite number of them, is a solution. So we say infinite solutions because it's the exact same line. It doesn't matter if y is 2 and x is 5, that'll work. x is 3, y is 3, that'll work. It doesn't really matter. X and y can be anything, and those two equations are going to be equal. They're the same equation. Of course, they're equal. So any point that's on one is also on the other there. Technically, I guess I shouldn't say every point is a solution. Every point on that line is a solution, and there is an infinite number. So whatever point is on that line would be a solution. So if y was 4, I think x would have to be -3, if that makes sense. The equations have to work. I was just spouting out numbers before. The equations do have to work. Nonlinear systems. This is section 11.8, and this is the tougher section for sure. But the concepts are exactly the same. Elimination or substitution. You can choose your poison here. I don't know. I see this as substitution, so I'm just going to solve this one for y and see what happens here. So if I solve this equation for y, I get y equals x squared. So now I'm going to take x squared and plug it in everywhere there is a y, I guess, right? So I get x minus, instead of y squared, it's going to be x squared equals 0. Wow. Okay, so this is a kind of interesting one. So I get x minus x to the 4th equals 0. I'm going to try to factor that. It might actually factor. So let's try this. We get 1 minus x to the 3rd. And actually, that actually factors. So I'm going to try to factor that using difference of cubes. So this is going to be using the difference of cubes formula, if you remember that from first semester. 1 minus x, this is 1 squared, minus 1x, plus x squared. Wait, sorry, minus, so this one's minus, that one's plus. Sorry, got it. Okay, yeah, that's right. Okay, so I'm just going to rewrite this over here and solve it. So I get x times 1 minus x times, I rewrite this in a different order. I'm saying x squared plus x plus 1 equals 0. So my solutions here are, depends if they're asking for real solutions or not. X equals 0 is the solution for this one. Set that equal to 0, so 1 minus x equals 0. So x equals 1 is the solution for this one. This one doesn't really factor, so I guess I'd have to do quadratic formula. So you go x equals, the option B is option 1. Plus or minus 5. This looks like fun, doesn't it? B squared is 1 minus 4 times 1 times 1 over 2 times 1. Plus or minus I root 3. When you simplify that, all over 2. So actually, those are the two imaginary solutions, and then these are the real solutions. So there are 4 solutions there. 2 of them are real, and 2 of them are imaginary there. So factor as much as you can. In that case, you could actually keep factoring. It's always a more powerful way to solve when you can factor things, for sure. Try this one. Well, this one, substitution, surely sounds like the best way because it's already solved for y. I'm just going to plug that in here for y into the other equation, right? So I get, let's see what happens, 4 minus x squared equals x squared minus 4. This one doesn't look as complicated. Let's see if this works. So I'm going to add x squared to both sides. 4 equals 2x squared minus 4. So I could set this equal to 0. I'm going to try to factor this. So I really prefer to set it equal to 0 and factor. It's a more powerful way to solve. And see if that does factor. I'm going to take out a 2 because I know a 2 will come out of there as a GCF. So x squared minus 4. Oh, I like that. Actually, it's pretty nice. So I get 0 equals 2 times x plus 2, x minus 2. So we get solutions of x equals -2 and x equals +2. And so I got 2 real solutions for that one, for that linear system. Oh, you know what I didn't do? So in this case, let's remember what we're doing. We're doing systems, right? So we're looking for ordered pairs. I'm not looking for just x values. Oh no! So here, wow. So I've got to solve. I'm only halfway done or partway done here. So my solutions are: I know there's a solution when x is 0. I don't know the y value. I know there's a solution when x equals 1. I don't know the y value. So you've got to plug in to one of these this one's solved for y, so I'm going to plug in. So if you plug in 0, you get y is 0. Okay, so I know that's one of the solutions. Plug in 1 squared is 1. Y, so those are two solutions. These are imaginary, so they're not going to be on the graph, so I'm not worried about the ordered pairs for those ones because it's imaginary solutions, not on the graph. So those are my two real solutions that are on the graph, which is probably what I'm looking for here, is real solutions here. Unless it says find all the solutions. So this one, so we've got to plug in. So I know my x value, one of my x values is 2, and the other value is x equals -2. And so let's plug in. So if you plug in a 2 there, 2 squared is 4 minus 4 is 0. And -2 squared is actually 4 minus 4 is 0. So those are my two solutions there. So again, we're trying to find the ordered pairs, 2, 0, and 0, or -2, 0. By the way, if I did graph these, and this is not part of this, but it might just help you to visualize what we're actually doing. We're solving a nonlinear system. So like this graph looks roughly, it looks something like this one here would be like, has a y-intercept of 4, kind of does this as a parabola, really rough graph there. This one has a y-intercept of -4. I should have drawn that first. And it roughly looks like this. And they cross at 2 points. They cross at 2, 0, and they cross at 0, 2, or -2, 0. So that's why we can sometimes have more than one solution. If you look at what these graphs actually do here, x equals y squared, I believe, looks something roughly like this. I think it goes through these 2 points. I'm not expecting you to graph these to solve them. This one, y squared, I hope you do know kind of what that one looks like, because we have memorized that graph. It goes through this point and this point. Looks something like this. So they cross at 0, 0, and they cross at 1, 1 there. So those two parabolas cross in 2 spots. So in these cases, we both had 2 solutions. But if you think about 2 parabolas crossing, like this could have happened. Maybe 2 parabolas cross in 4 different spots, right? So you would have 4 different ordered pairs. So be on the lookout for some of the homework problems where you're going to get way more than one solution, maybe up to 4 solutions. I don't think you would have more than 4 solutions, but you're going to have a number of solutions here. So use the graphing method. So it says graphing method is solve for y, right? And graph these guys. So we're going to solve this for y. So we get 3y equals -x plus 2. Sorry, there's 2. Divide by 3, divide by 3, sorry, positive 3, divide by 3. You get y equals -1/3 x plus 2/3. You're going to graph that in your calculator. Solve this one for y. It takes a little bit more work. So we get y squared equals -x squared plus 25. Take the square root of both sides. Don't forget, plus or minus. You get y equals plus or minus the square root of, by the way, this does not simplify. Like it's just -x squared plus 25. Don't try to butcher that and try to factor it. There's no square root of that. It's just -x squared plus 25. It does factor actually, 5 minus x, 5 plus x, but that's not a square root. It's not the same factor twice. So we're going to graph both those. So let's see what this looks like. So on the calculator, let's try to graph everything here. So this is going to be kind of weird. Some of these are kind of weird. Anytime you're dealing with nonlinear, it's tougher stuff. X plus 2/3. This one's very straightforward, right? It's just a linear line there. So we're trying to find out where this shape, you might even know what shape this is. This should be a circle, right? That's in the form of a circle, so I'm expecting a circle. But we have to graph it as 2 different functions here. So the first one's going to be the positive case. So square root of x, or -x, sorry, square root. thought I typed square root of negative x squared plus 25. And I'm going to graph the next function. It's negative, so this one actually is negative, square root of negative x squared plus 25. So I did the positive case. This should be the bottom half of that circle. And again, I'm trying to find out where the circle intersects that linear line. So I think I'll have to do the intersection tool point twice, because I see the circle intersects the pink part of the circle there and the green part of the circle there. So because there's different functions, I think I'll have to do this twice. So menu, geometry, points and lines, intersection point. Click the black and the pink there. I found that answer. Click the green and the black. I found that answer. So I actually have two ordered pairs. So one of them is that one, and one of them is this one. So I would write down both of those ordered pairs. The answers are -4 points. So the nice thing, I want my answers in terms of an ordered pair, so they're already in the right form. And this one is 4.91 comma -0.968. Okay, pretty tough, challenging problem there for sure. What method would you use here? So it's a nonlinear system. I typically like substitution for nonlinear, so I would probably use that. I guess you could use graphing as well, but it seems to me, x equals 2y plus 2. We're going to plug that in everywhere there's an x, which is there, and plug in there, right? So, oh my goodness, this is going to be so much work. So let's see what happens. So y squared minus, this ends up being 2y plus 2 squared equals 2 times 2y plus 2 plus 4. So I had to plug it in twice there. Everywhere there's an x, I plugged in with parentheses 2y plus 2, which means this one, we're going to have to FOIL this guy, right? So it's going to be y squared. Wow. Okay, so this is in parentheses. If I FOIL that, it's going to be 4y squared plus 4y plus 8y plus 4 equals 4y plus 4 plus 4. I'm going to distribute there. I'm going to just distribute here, so I get y squared minus 4y squared minus 8y minus 4 equals 4y plus 8. I'm going to subtract those two guys, so subtract 4y here. Subtract 8. I get equals 0 over here. These two go together, so that'd be -3y squared minus 12y minus 12. I see at GCF, I want to take out the negative right away because I don't like that at all. Y squared plus 4y plus 4. I took out a negative there. And let's see what happens here. So we get -3 times, hoping this factors, I think it does. So y and y, 2 and 2 probably, plus and plus. I think that works. So I get y equals -2 and y equals -2. So I get the same answer twice. Okay, so I get y is -2. Okay, so I know that my y value is -2, but I don't know what my x value is, right? So at this point, you could plug into this equation, right? So x equals 2y plus 2, so this would be 2 times -2 plus 2, which is -4 plus 2, which is -2. Let me double check that. -4 plus 2 is -2. So I get -2 comma -2. So I do get a solution here that they do cross those two equations. You have a solution. So it just takes a lot of work to get there. What method here in this one? Again, you can always graph it, solve for y. That'd be tough though on the left-hand side. At least you'd have to be another kind of circle or maybe probably ellipse type thing. Actually, we don't even have to know what the shapes are to solve it algebraically here. The thing I see, well, let's try. Do you want to try? Let's try elimination. So let's see what happens. So I'm going to multiply this one by -2. So I'm multiplying everything here by -2 and write it down below here. So I get -2x squared. -2 times 2 is -4y squared. Okay, that's weird. Equals -4. So I'm going to add these up. So the x terms go away. I like that. The y terms don't really go away. So I get -4y squared minus 3y equals, if I add, I'm adding here, so I get 11. Wow. Okay, so this one, well, at least it's all y though. That's nice. I'm going to multiply everything by, I'm going to get everything over to the right-hand side there. So 0 equals 4y squared plus 3y plus 11. So factors of 44 that add up to be 3. So I think 11 and 8 could work. No, 11 and 4, no. 11 and 4, no. Let's try 2 and 22, 4 and 11, 5, 6. So this is really not an easy problem. So if I try quadratic formula, let's see what happens. So this would be opposite of 3 plus or minus square root of b squared would be 9 minus 4 times 4 times 11 all over 2 times 4. Here's the thing, this guy is going to be negative, which means this is imaginary, which means I don't need it, right? I'm only looking for real solutions right now. We're trying to find ordered pairs on the graph. So I think in this one, those two shapes, whatever they might be, one's probably a parabola, the other one is probably an ellipse. So they might, be kind of a parabola and ellipse, and they, for some reason, they don't touch at all. So they don't have any intersection points that go through them. So hopefully your problems won't be quite that hard, but I tried to tackle some weird cases there. You'll definitely see a few of those at 11-8. So if you have trouble on the homework, please ask and I'll help you out the next day. We'll go over some of those tough homework problems. That's it.